Hello everyone, welcome back to the Aspentech channel, and this video is a bit unique in its nature, and I have decided to make this video as a question answer session with the Aspentech channel Dr. Mohammed Haris Hamayun. Obviously, I am trying my level best to address all the comments which have been asked in the video, but obviously there are some few important comments or the important points which I thought that these must be shared with my valuable viewers for a clear understanding of the concepts which we have applied earlier. So I have selected top 8 comments. Obviously, other comments are also very important, but this is the first round of question answer session, so I will pick up other comments in our upcoming videos, and one by one I will answer all these comments for a clear understanding of the concepts which we have applied, which we have used in Aspen videos using either Aspen HYSYS, Aspen Plus, Aspen Exchanger design and rating. So going to the question number 1, the question number 1 which is asked is condensation possible with cooler? Obviously, the cooler is a shortcut way of doing the things, and you can do condensation phenomena over there. But obviously, once you are using the heat exchanger, the proper type of heat X in Aspen Plus or rigorous heat exchanger in Aspen HYSYS, then obviously you have to take care of all the aspects which is covering it. For example, you have to consider the flow rates, the temperature conditions, and so on. But in cooler, which is either in Aspen HYSYS or in Aspen Plus, you have to simply specify vapor fraction as 0 and you will get the condensate. Similarly, if you want to do the boiling phenomena or the superheating phenomena, you can simply specify vapor fraction or temperature and you can get these. But in rigorous case, it would be a bit different. Going to the question number 2, how to perform exergy analysis for the expander? Is it the same process? Yes, it is the same process, that you need to calculate the exergy of inlet stream, you need to calculate the exergy of the outlet stream, and obviously you would know that how much power it is producing. Obviously, in that video, the compressor was used, and compressor takes power for the operation, requires energy for its operation, while the turbine produces power. So the formula will be a bit different, and the formula is percentage exergy efficiency is equal to work divided by exergy of inlet stream minus exergy of outlet stream. Obviously, in the case of turbine, power is producing, so the outlet stream exergy will be lower than the inlet stream exergy, and definitely it is in minus E out. While in case of compressors, the phenomena is opposite. You are adding the energy to the outlet stream, you are increasing its pressure, you are increasing its temperature, while in case of turbine, the phenomena is reverse. So obviously the formula is not only reversed, but the terms are also reversed, because for compressor it is E out minus E in over W, while in case of turbine it is W over E in minus E out. Going to the question number 3, can you please inform me from where did we found out the values of standard exergies for different components? This data is easily available in literature. Like if you go to the Google, you simply click that standard chemical exergy values for nitrogen, for oxygen, for argon, for water, for methane, anything. A table will come. Obviously, I can't share over here due to some reasons, but it can be easily taken from the literature and you can do the chemical exergy values, because currently the chemical exergy calculations are not incorporated in Aspen. What we get by specifying the reference conditions, we can get the physical exergy values, and then we go to the Excel, we apply the formulas over there and we can get the values of chemical exergy. There is another way of doing chemical exergy in Aspen is to use the calculator block, but we will be doing that in our upcoming videos. So I would request, please stay tuned on this channel for upcoming videos where we will be doing the exergy analysis, the chemical exergy analysis, in fact, using calculator block. Going to the question number 4, stream S3 goes into the heater at 900 plus degrees centigrade and comes out at 500 degrees centigrade. That seems odd. Yes, definitely, that seems obviously odd, but it's a heater. You have to understand that in a shortcut method, we can do whatever we want to do. There is no restriction over here. Obviously, this is a huge delta T, 400 degrees centigrade. But once we are using a heat exchanger, obviously taking that much delta T or that much heat out or that much heat transfer not possible in a single exchanger, or else we have to install a very long or very high surface area heat exchanger. So we divide it into 2 or 3 heat exchangers with the delta T range. But obviously, in case of heater, that is possible because we are simply representing the method. We are simply representing the phenomena. We are not going into the details. So what we are doing once we are taking the shortcut column, or once we are taking the shortcut reactor, once we are taking the shortcut heat exchanger, these things are possible. But when we are going to the PFR or rigorous columns or rigorous heat exchangers, then things are different. Going to the question number 5. Hi, would you please tell me how did you align block B7 immediately? Obviously, I have explained it that first use Control A and it will select all the flow sheet, then simply press Control B and it will align automatically. This is a very good method, and obviously I would like to acknowledge my student Mr. Ahmed Mustafa, who has actually invented that process and informed me that, my respected sir, this is also possible in Aspen Plus, and it was again my duty to inform my valuable viewers, my students who are also listening to these videos. Going to the question number 6. Instead of putting a heater and a cooler, can we put one heat exchanger which uses heat from the reaction to heat the fluid? Definitely that is possible. But again, the concept is same. We are just representing the process. Obviously, we can use the reactor outlet product which is at high temperature to heat up the feed. That is a very conventional process, or you can say that is advanced process in the future to extract the heat from the stream which is either waste stream or of not use, or of to decrease the temperature to meet the requirements of the upcoming process. So yes, like for example in the dehydrogenation reactor, where you are injecting the feed or giving the feed preheating is required. So you can this preheat this feed by the product from this reactor. So these possibilities are possible in case of different processes. But again, as I said before, we are using simple representation for the understanding of the process, because first, when you understand the process, then you can do the calculations, the manipulations, can complex it. But for the first time, we need to be as simple as we could, so that the process converges and we get the understanding of the process. Going to question number 7. In the open loop process of ammonia production, is it necessary to recycle the stream? It is not. Open loop means that the loop is not closed. Once you recycle the stream, the loop will be closed. And without recycling, like if a process is unidirectional, or even if it's not unidirectional, but for example, if a product is recycled back to the process, then we call it as a closed loop. And if it is not recycled, then we will call it as a open loop. So the open loop, control, closed loop, these are also basic concepts of the control loop as well. Going to the last question for today. I want to ask, can I simulate reverse osmosis plant in Aspen? I have received a lot of questions regarding this, and that's why I thought to answer it in the first go of question answer session. Unfortunately, you can't, unless you have a very good command on Aspen custom modeler, where you can write the Fortran and develop a model and take it to the Aspen Plus. Then it is definitely possible. Like one of my colleague has done her master's, and she has created a membrane module in Aspen Custom Modeler, and then she took it to Aspen Plus and had simulated the process. But again, it requires a lot of understanding of the Fortran language. Obviously, we as chemical engineers are definitely not good at it, but the persons from the CS or the computer science background have the good knowledge of it. So yes, that is possible, but currently that is not available in Aspen. And if you want to do that, you have to simply write the codes in Aspen Custom Modeler and then bring the model in Aspen Plus. So that's it from this first question answer session with Aspentech channel Dr. Muhammad Haris Humayun. I hope you have enjoyed this session and have learned few aspects which were probably not covered, or maybe covered but now would be more clarified to you. So that's it from this lecture. Thank you so much. Please do watch, like, share the video and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos.